Hi all, this is my second video of Simple Harmonic Motion. In the first video, we have discussed until to get the relationship between the velocity and the distance. Simple Harmonic Motion. I'll consider the same diagram what we had discussed earlier. Then this is the point A, the point B, the point O is the equilibrium point, and the particle is here. Distance from the equilibrium point is x. Then the velocity is x dot, and the acceleration of the particle is x double dot. We got a relationship x dot is equal to omega times a square minus x square. However, we know that x dot is dx over dt. It is equal to omega times a square minus x square. Now, there is a differential equation. We have to separate the variable to solve this differential equation. Dx over a square minus x square is equal to omega dt. I have to integrate both sides. Now, the left hand side of this integration is equal to, we know that dx over square root of a square minus x square is equal to sine inverse x over a is equal to omega t plus c, where c is the integral constant. Now we have to use the boundary values to get the value of c. What is where we know that when t is equal to 0, x is equal to 0. Therefore, sine inverse 0 is 0. 0 plus c. Therefore, c is equal to 0. Now, then the earlier relationship can be written as omega t. Here, x over a is equal to now sine omega t, sine inverse. Now it becomes sine. Then x is equal to a sine omega t. This is one of the most important relationship or the equation or the formula of the simple harmonic motion, which had the relationship between the time and the distance. Let's go to the next step. Here already we know that the relationship between the distance and the time, which is if the distance is x, x is equal to a sine omega t, where x is the distance and t is the time. Okay. Now I'll consider my diagram again. The diagram is this. This is A, this is B, and this is O is here. The particle is moving here, the particle. The distance from O to the particle is x. Then we know that this is x dot is the velocity, x double dot is the acceleration of the particle. However, if I consider another option, the earlier option is x is equal to a sine omega t. This is the relationship between the time and the distance. If I consider when t is equal to 0, x is equal to a, this relationship that x is equal to a sine omega t can be written as x is equal to a cos omega t. This is the other relationship of the distance and the time, or the simple harmonic motion. Okay, now we will consider the nature of simple harmonic motion. We know that cos omega t is always in between positive 1 and negative 1. Therefore, if we multiply by A cos omega t is in between positive A cos omega t is in between positive A and negative A. That means A cos omega t is x is in between A and in negative A and positive A, where A is the amplitude of the simple harmonic motion, where A is called the amplitude. Of SHM, simple harmonic motion. Now, okay, the next one, we know the relationship of the distance and the time is x is equal to a sine omega t, or x is equal to a cos omega t. Since x is equal to a cos, I'll write it as omega t plus 2 pi, because the period of the function is 2 pi. Now, this is cos. If I take omega out, t plus 2 pi over omega. Here, think about this. When t is equal to t and t is equal to 2 pi over omega, the distance of the particle, or the x has the same value. That means where 2 pi over omega is called the period of the particle. Period of the particle. Now I am going to discuss the relationship between the circular motion and the simple harmonic motion. I'll draw a circle. This is a circle. The center is O, and the radius is R. There is a particle which is at A when t is equal to 0, which is at B when t is equal to t. However, the linear velocity of the particle is constant value. I'll take the linear velocity as v. Linear velocity of the particle is v, and the angle subtended at the center by the arc AB is theta. Then we note that d theta over dt, or theta dot, is the angular velocity of the particle, angular velocity of the particle. Now, if we think about the projection of the particle is at, then I'll take the particle as P, the projection of the particle is Q. The distance from the O, the center, to the projection is x. Then we know that we can write it x is equal to r cos theta. We can write x is equal to r cos theta. Then dx over dt is equal to d over dt r cos theta. I is a constant. Dx over dt we can write it as x dot r d over dt cos theta. Here we have to use the chain rule. R d over d theta cos theta times d theta over dt. This is negative sine theta. What is d theta over dt is theta dot. However, x dot can be written as negative r theta dot sine theta. Since v is a constant, we can say the angular velocity also constant. I'll take let theta dot is equal to omega. Therefore, x dot can be written as negative r omega sine theta. Now, I differentiate this equation. Again, dx dot over dt is equal to d over dt negative r omega sine theta. What is it? Negative r omega d over dt sine theta. This can be written as r omega d over d theta sine theta times d theta over dt. Negative r omega, this is cos theta times theta dot. This is, however, theta dot is omega, negative r omega square cos theta. We know that x is equal to r cos theta. Therefore, x double dot can be written as negative omega square x. This is the, we know that this is the first equation or the characteristic equation of the simple harmonic motion. Okay. We know the x dot is equal to negative r omega sine theta. Then if I square both sides, x dot square is equal to r square omega square sine square theta. X dot square is equal to omega square r square. What is sine square? 1 minus cos square theta. X dot square is omega square r square minus r square cos square theta. What is it? R cos theta is, we know that x omega square r square minus x square, x dot square. This is the second equation of the simple harmonic motion. That means the relationship between the velocity and the distance of the particle. If a particle is moving on a circle, its projection is having a simple harmonic motion on its diameter.